Welcome to your video on factoring quadratic trinomials when the a coefficient is 1. Please take notes on the notes page that's been provided to you. We're going to begin by doing some expansion and noticing of a pattern. Let's begin with this one. When you expand that, it means that multiply out the parentheses. That multiplies into x squared plus 3x plus 6x plus 18. Again, you multiply x by 3, 6 by x, and 6 by 3. Rather than combining these, let's keep them like this so that we can notice the pattern. So I'm going to rewrite it like this. Notice if you were combining these, you would do 3 plus 6, and it would be 9x. So I'm just going to write it like this, 3 plus 6x. This 18 I've rewritten as 3 times 6. Let's do another one. X minus 5 times x plus 2. We'll do it the same way. Multiply through, you get x squared plus 2x minus 5x minus 10. Again, rather than combining those, we're going to write it out like this, 2 minus 5x. And negative 10 is actually 2 times negative 5. Now, if you look at those closely, you'll see there's a pattern there. Here we began with 6 and 3, and in the final expanded form here, we have 3 plus 6, so we're adding those two numbers, and at the end we have 3 times 6, so we're multiplying those. So here's the sum, and here's the product. In this one, let's check if it's the same thing. We have negative 5 and a 2. Down here we have 2 plus negative 5, or 2 minus 5, it's the same thing. So we're doing the sum of the two numbers, and at the end we have the product of the two numbers. So that brings us to an important point about quadratic trinomials. When we have two binomials multiplied by each other, so x plus p, x plus q, p and q represent any number, that expands to, when you multiply into this form, x squared plus the sum of those two numbers, the p and the q, x plus, and then at the end, the product of those two numbers, just like we had here, the sum of the two numbers and the product of the two numbers. Important rule to remember, especially when we go backwards from this form back to this form, which is factored form. So now we're going to use a technique called x factor. It's one of many factoring techniques for quadratic trinomials. There's many ways to do these. This is one technique that I have found works very well for many students. All right, we're going to use this technique when a equals 1. So what does that mean? First of all, a is the first coefficient. In this case, we don't see a number there. We have 1x squared, so that's a 1 there. B value is the second coefficient, 3, and C value is the third coefficient, negative 28. For x factor, we draw an x. That's why it's called x factor. In top, we always put a times c. On the bottom, we always put b. So a times c is that 1 times negative 28, which is negative 28. The b value is 3, so we write that here. Then in x factor technique, our goal is to find two numbers that we're going to put in these two spots. Those two numbers, when they are multiplied, they give us negative 28. So the product is negative 28. And those two numbers, when we find the sum, when we add them, should be 3. So that should remind you of what we just did with the p and the q in the last pattern that we noticed. So two numbers. First of all, 28. 1 times 28. 2 times 14. 3 times nothing. No. 4 times 7. Okay, I'm going to pause there because 4 times 7 is going to give us negative 28. 4 times 7 will give us 28. And 4 and 7 combined also have a difference of 3. So to get negative 28, we're going to need one of them to be negative. So I'm going to write it like this. So 7 times negative 4, that makes negative 28. And 7 plus negative 4 is 3. So I found two numbers that multiply to that, two numbers that also add to this. So that is what we have going on there. Those two numbers multiplied, those two numbers added, and that tells us the factored form of this must be this, x plus 7 times x minus 4. Again, let's think back to the p and q. So when we had this and we multiplied it, we noticed that in the end we would have x squared, which is here, and then in the middle we had 7 plus that number, which is 3, and at the end we had 7 times that number, which is negative 28. So here's the sum of the two numbers, and here's the product of the two numbers. All right, so try this one. Let's check our work. So ABC, A times C is 1 times 48, which is 48. B value is 14. Now two numbers that make 48. 1 times 48, but that doesn't add to 14. 2 times 24, but that doesn't add to 14. 3 times 16, that does not add to 14 either. 4 times 12, no good. 5 times something, no. 6 times something, 6 times 8. Hey, that works. 6 times 8 makes 48, and 6 plus 8 makes 14. So the numbers must be 6 and 8, right? Because they multiply to 48, and they have a sum of 14. So that means the factored form must be x plus 8, x plus 6. We use those two numbers. Again, think of P and Q. Here, the sum of the two numbers, so 8 plus 6, 14. And here, the multiplication of the two numbers, 8 times 6. Try another one. All right, let's set it up. X factor A, B, C, A times C, 1 times negative 20 is negative 20. And then the B value is negative 1. Negative 1. Two numbers that multiply to 20. 1 times 20, 2 times 10, 3, no, 4 times 5. Oh, let's pause. 4 and 5. One of us is going to be negative because that's making negative 20. And 4 and 5 have a difference of 1, so it must be. I put negative 5 and 4. Why did I choose negative 5 instead of negative 4? Because these two have a sum of negative 1. Negative 5 times 4 makes negative 20. So again, those two multiply to make negative 20. Those two added up, or their sum, is negative 1. So it fits the rule. That means the factored form is x minus 5, x plus 4. And if you think of these in terms of P and Q again, the middle here is the sum, and the end is the product. So the sum of negative 5 and 4 is negative 1, and the product of negative 5 and 4 is negative 20. Great. Now we're going to look at the ones on the bottom of your page. Here it says factor using the shortcuts. Well, the shortcut for this one, we've learned that there's a factoring shortcut called factor out the GCF, right? The greatest common factor means look what's common here and pull it out. I see x squared and x, so x is common. So x comes out, and we have x plus 10 left in there. If you multiply this back, x times x, or x times 10, you get back to here. So we have fully factored form. Next one, what's the shortcut for this one? Well, whenever you see two things with a minus sign, you should automatically be thinking, hey, maybe it's a difference of squares. So here's something squared minus something squared. Yeah, it definitely is. This is x squared, this is 4 squared. So we have that thing squared minus that thing squared. Those ones always factor into x minus 4, x plus 4. It's always that thing minus that thing, and then that thing plus that thing. There's how a difference of squares always factors. Next, we have a perfect square trinomial. All right, this one, you may know the rule. We just worked on it. You look at it, you're like, is this something squared? Is this something squared? Yes, they both are. Okay, if these are both squares, then we look at the middle one. Is this one 2 times those two things? And I think it is. Let's check. So the first thing is x squared. The last thing is 4 squared. And in the middle, we have 2 times those two pieces, 2 times 4x, which is 4 and x. So that is 8x. Yep, it works. So this thing is a perfect square trinomial. And perfect square trinomials factor like this: x plus 4, and then squared. All right, we always look at the first thing, this sign, and the last thing, squared. If you multiply this out, you'd get back to here. So that is the factored form. All right, we're going to take those same three, and now we're going to use the x factor method. Why? Because it's important to see that if you forget the shortcuts, you can always rely on x factor to factor anything. This thing, however, is not a trinomial. We need it to be a trinomial to use x factor. So I see x squared, I see x, we're missing the last term. So why don't we rewrite it like this? Same thing, but we just put 0 at the end. So now setting up x factor, a, b, c. A times C is 1 times 0, so that's going to be 0. And the B value is going to be this value here, 10. Now you're thinking of two numbers that multiply to make 0 and add up to 10. Well, the only way to get 0 is to do 0 times something. so it's going to be 0 times something, but those numbers have to add to 10, so it has to be 0 plus 10. So the numbers must be 0 and 10. 0 and 10, all right. So by x factor, well, they multiply to 0, they add to 10. By x factor, then we have x plus 0 and x plus 10, which is here. And x plus 0 is just x, so we end up with this. If you look above, you'll notice that this matches exactly the factored form we got when we did the greatest common factor. All right, let's look at the second one then. We had that difference of squares. Let's try this one with x factor. So first of all, this one has an x squared and a number, so it was missing the x term. Every quadratic has x squared, x, and a number, right? So we'll put 0x there to fill in the gap. Now we have a, b, c. All right, a times c on top, b on bottom. 1 times negative 16 is a times c, and b value is 0, so 0 goes in here. So now two numbers that you multiply to make negative 16, and those two numbers must add up to 0. The only numbers that can add up to 0 are a positive and a negative version of itself. So what are two numbers that make 16? Well, 4 and negative 4. Again, 4 times negative 4 is negative 16, but 4 plus negative 4 is 0, so it fits the rule. That means factored form is x plus 4, x minus 4, x plus 4, x minus 4. And again, that works. Our difference of squares tells us that that's the factored form as well. Now let's look at the last one, which is a perfect squared trinomial. If you forget the perfect squared trinomial rule, well, this is already a trinomial, so we can go right to x factor. A, B, C, a times c on top, b on bottom. 1 times 16 is 16. On the bottom, we have b value of 8, and then two numbers that multiply to make 16. The same two numbers must add up to 8. And those two numbers are 4. 4 times 4 is 16. 4 plus 4 is 8. 4 times 4 is 16. 4 plus 4 is 8. So it works. Factored form then must be x plus 4 times x plus 4. X plus 4, x plus 4. And that simplifies to x plus 4 squared. And perfect squared trinomial, that's what it factors into. So everything matches up. Good work. Hope this video is helpful for this basic factoring. Now work on the rest of the problems on the practice packet.